So we look at our plans here, and like I identified before, we have A, B, C. So A and C are going to fold up to be the sides, and the tabs will fold up to hold the ends in. Okay? So when we do the layout, we do what we can to avoid any kind of human error. So the more tools we can use that eliminate human error, the better. And we try to make them as elementary tools as possible because I want them to be tools that you're going to have at your disposal in the future. So the first thing I want to do is I want to create these half-inch tabs that are going to go on the ends here. So I think that most people, when they see a problem like that, they would take a ruler and they would measure half inch on both ends of this, and then take the straight edge and go ahead and draw that line across. The human error there exists in, when you mark the half-inch line, you could be off by a 32nd, 16th. And then you mark the other half-inch, you could be off by a 32nd, 16th. So you could be off by as much as an 1/8 of an inch at an angle so it doesn't run parallel to the edge. And then do the same thing on the other side, and it could be off again by as much as an 1/8 of an inch. So then you have no longer that 7 inches that you're required to have on the inside there. The next project beyond the box is going to be this. This is the marking gauge. This is for scribing lines, specifically on wood. I use this for woodworking. It goes ahead and puts a cut into the material that a chisel can sit into. The one that I use in woodworking is this one here. Same thing, just has a fence and a cutter. And that's used to square material. Tough to see that line, but that line there is now a place where the chisel is going to fall into. Okay? So we're going to use it on here by just scratching. So I'm not going to use this one here because this is more for cutting into the material. This one works well for scratching, however. It's a half-inch tab, so we want the distance from our fence and our point to be a half-inch. Right now, we're there. Okay? The way to adjust this, however, would be to loosen this set screw, and you can move that fence along its length. Set it, bring it up to the half-inch mark, and lock it. Once you have it locked, just check and see that it didn't shift on you. That looks pretty good. So I'm going to go ahead and I'm going to scratch those lines on here. So I'll hold it with my left hand. I'll put my fence against the edge of the material, and my tip pointed down so I can go ahead and drag it across and put a scratch mark, which is a half-inch from the edge on that side. Now I'll flip it and do the same thing. So I've eliminated human error, and I have guaranteed myself that this tab and this tab are identical in width. So I've done two things, and it was pretty easy, right? Pretty effortless. Now I want to go ahead and I want to mark these lines here between the A and the B and the B and C. And they are 2 1/4 inches in each. I could set this now 2 1/4 inches. So we're at 2 1/4. Okay. That's one way of doing it. Now I just take this piece and I would scribe that along like this. The greater distance I have between my cutter and my fence, though, it makes this thing a little bit more wobbly. So we're going to use instead a combination square. It's a combination square because it has a combination of items on here. It has a 90-degree angle, it has a 45-degree angle, it has a level, it has a depth. If I wanted to duplicate the thickness of this material, I'll just bring that down to that thickness there, lock it, and then I can go ahead and I can identify that thickness on a different piece of material if I wanted to fit into it. Here, we're setting it so that it's just over, there's my 2 1/4 mark right here. I want to be covering it up with my with my fence. Okay? Now I'm going to use this to run across to draw my line on here. When you work by yourself though, you have to have ways to stabilize your material. So we've been putting a lot of material in vices and so forth. Here I'm just going to go ahead and hold those there so that I can take my marker and my combination square. Hold it to the front edge there and then use that to follow along. Take my clamps off, spin the material, and just do the same thing again. Could I have used this to do my 1/2 inch? Yeah, I could have. And it would have been as accurate as what I did with the marking gauge. But I wanted to show you two different layouts of this. Alright? What's left to do? Let's look at our drawing. So we should have 5 1/4 in between, which we do, and 1/2 inch tabs at the ends here. And now we have to go ahead and put 45-degree angles in here. So we're going to be putting our folds up. So we have our tabs lifted up, and then we fold that up to a 90-degree angle. We want our angle to be right at this intersection here, to meet right where our scratch line from our marking gauge was and the line that we made with our Sharpie. So I'm going to go ahead and do that to each corner here. What is the most dangerous aspect of working with this sheet metal? Well, number one, not the edges so much, because the table shears does a nice job of putting a nice square edge on there so it's not sharp. The corners, however, are still very sharp. Okay? And we also want to cut out these triangles now. We're going to use a pair of tin snips for doing that. Understand though that the tin snips have this serrated edge on them. Okay, the serrated edge is there to keep this thing sharper longer. You know, yesteryear, your grandparents would have worked with a pair of snips that had a straight edge on them, and it would have required that they would be sharpened periodically. And so they would buy one nice pair of pin snips, and they would have it for their entire career, sharpened multiple times in the interim. When we cut these corners out, these triangles, I want you to wear glasses, because if your cut goes through on the second pass here, the triangle can pop out. So that popped up and hit the underside of my hand. This now gets discarded. And that serrated edge that I talked about has been transferred onto this material. And that is now sharp. When we fold it up, they're going to be facing one another, so it won't be something that you can come in contact with. When we cut these triangles out, we also want to make sure that we're cutting out the lines so that we have enough area to bend in. So when you cut that triangle out, it should be that on this triangle, if it doesn't cut all the way, you have to twist the metal and that'll break it off. Do not try to just pull it off straight. Cut the other ones out. Our lines are on our triangle, and we have plenty. Let's go over and bend it.